Now, according to the algorithm that we have discussed, let's go ahead and write the Java logic for finding a particular value in a infinite numbered sorted array. So here, according to our algorithm, we came to conclusion that we will be writing the solution exactly that is similar to exponential searching algorithm, right? So here in the previous videos, we have already implemented the exponential searching algorithm. So what I will do is I will copy this entire implementation and I will paste it into my class that we have here. Remember that I can obviously create the object of this exponential search class inside this search in infinite sorted numbers class, and I can use it, but I'm just copy pasting this logic so that we will have better readability when I paste this code in codingpal.org's code snippets. Okay, now as part of the main function that we have here, what we will do, we will simply call the search in infinite sorted arrays, this dot exponential search function, and we will pass the array and we will pass the value. Okay, so not even a single line of change is required, but I will tell you some of the changes that you can still do and the logic would still work in this problem. When we implemented the exponential searching algorithm, we did not consider the array that we get has infinite number of values. That is the reason why while calculating the range as well as while finding the last index for the binary searching algorithm, we have put some checks on the length of the array. Okay, but in this problem, the array that we get has infinite number of values, so it will never ever end. That is the reason why you can still remove these checks and our logic would still work absolutely fine, because the array that we have is a infinite numbered array as well as sorted array too. Okay, that is the reason why we are employing it. If at all, if you want to remove this, you can remove it, but I will not remove it. I will still keep them in place because it will basically produce much readable code, as well as it will cover the corner cases as well. If at all, if some user passes a array which has a end. That is the implementation. Remember that whenever you read the problem for the first time, you will not think of binary searching algorithm, obviously, because as soon as you hear it has an infinite number of values, you will not know what is the end, right? Obviously, when you don't know the end, you will not be able to apply the binary searching algorithm. That is the reason why first here we are trying to find the range, search range in which the value that user has passed might be available, and based on that search range, then we are applying the binary searching technique. Okay, so that is the implementation. Now to test this, obviously we will have to create a infinite numbered array, which is not possible. That is the reason why here let's just assume that whatever the array that I have created and passed has an infinite number of values, and in this infinite number of values I want to search for the value 20, and the value 20 is available, right? So it should basically return the index of 20, and let me just run it as Java application and see the output that we have gotten is 12. That means at index 12 the value 20 is present. So let's just go ahead and count the indexes, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 20 is present at index 12 and 12 is what we have gotten. Now here let's just assume that I'm searching for the value 22. 22 is not present, right? So if I run this, output should be -1. So -1 is what we have gotten. If that is not the case, let's just assume that I'm searching for the value 12. 12 is present, right? So if I run this now, see the output is 7. Index 7 has the value 12. If at all I'm looking for the value 8, 8 is not there, right? 7 is there, 9 is there, 8 is not there. So it should return -1. -1 is what we have gotten. If at all, if I pass -8, -8 is also not there. So if I run this, see the output is -1. Similarly, you can pass any value based on its availability. It will return its index, or if it's not available, it will return -1. Here 1 is present at index 0, so we've gotten 0. Okay, so that is how in a smart way we apply the binary searching technique for finding a value in an infinite numbered sorted array. Okay, so that's it for this one. I'll see you in the next problem.